We present our study, Perceptually Calibrated Foveated Chroma Attenuation for Gaze Contingent VR Rendering in Displays. Conventional stereo rendering uses full color over the displays. However, humans' peripheral color perception is limited. Neurophysiological evidence suggests that color perception deteriorates with increasing eccentricity. Not only that, the ability of different color perception with increasing eccentricity is different. This asymmetric nature of color perception motivates our foveated chroma attenuation method for eye-tracked VR rendering. Consequently, we come with two hypotheses. First, foveated color rendering is difficult to distinguish from uniform color rendering under the employed sequential viewing protocol. And, second, foveated color rendering does not increase perceived distraction compared with uniform color rendering. We first convert the RGB to YCBCR color space. Then we employed Tukey by-weight function for CB and raised cosine function for CR channel. In this way, we preserved more blue color than red-green color. This aligns with human perception as well. The functions are eccentricity and degradation weight dependent. With two calibration studies, we have derived a range of degradation weight, 0.70 to 0.85 for the CB and 0.35 to 0.55 for the CR channel. In the main study with 26 participants, we evaluate our derived degradation weights in a modified sequential triangulation procedure. In this study design, two uniform color references and one foveated color target were presented consecutively in randomized order. The three pairs of pre-selected degradation weights were from our calibration study minimum, 0.70, 0.35, average, 0.775, 0.45, and maximum, 0.85, 0.55. The weights were assigned randomly. The final results show that 17.7% participants identified the foveated color target, while 62.7% judged the foveated color as not more distracting. These outcomes support our hypotheses. Next, we will present the 6 virtual scenes used during user studies. Each scene are presented with 3 degradation weights with dynamic gaze positions. Other than the perceptual study, we evaluate our foveated chroma attenuation with power consumption and video compression. For power consumption measurement, we used a custom setup with WiseCoco 3.81-inch micro OLED stereo display, Arduino UNO-R3, and INA 219 current sensor. We have, on average, 0.19% power saving during static scene condition and 0.53% power saving during dynamic scene condition. For video compression, we used FFmpeg software and two video encoding, H.264 and HEVC. On average, we have 3.07% compression gain for H.264 and 3.28% for HEVC encoding. So the main takeaways from this study as follows. First, foveated chroma attenuation is a viable perception-driven component for gaze-contingent VR rendering. Separating CB and CR channels in YCBCR match the asymmetry of peripheral color sensitivity. Second, the perceptual detectability for foveated color stayed low, while distraction did not increase. Third, the power and compression gains were moderate, but repeatable and directionally useful. Finally, we would sincerely thank you for your time and evaluation.